Hello everyone, welcome back. We are here again with Season 1 of Database Deep Dive. We've made it up here to Episode 8 now, so show is still going strong. I'm joined today by an amazing guest, Mohan, but I'll have him introduce himself in a second. For those of you who are just tuning in for the first time, my name is Nick Walsh, and I am a technical evangelist here on the team at AWS, and I'm here helping to bring this awesome show to life every week. Oh, we have some audio issues in the chat. So someone says we have double audio, and someone else says that there is no audio. Chat, can you help us? Oh, okay, so is the double audio any better right now, or is it worse? We have two mics going, so trying to... Okay, it's good now. So I'll try to speak over into this mic to try and reduce that. So
okay,
cool. Thank you, chat. Debugging at its finest. Pair programming, right?
Exactly.
Awesome.
Real time, everything real time.
Real-time applications, real-time debugging.
Yeah, exactly.
Real-time solutions. Perfect.
Yeah.
So thank you for that, ID Thief, over in the chat. So yeah, again, Season 1, Episode 8. Today, topic of discussion is going to be Redis and Amazon ElastiCache.
Yeah.
So before we get into that, Mohan, why don't you introduce yourself? Tell everyone why you are the expert that everyone is excited to have on the show.
Correct. Yeah, the expert, yes. Good afternoon to everyone. My name is Mohan. I'm a senior manager in Amazon ElastiCache team. I've been with Amazon for last 7 years and last 2 years with ElastiCache team. And have been meeting Nick today, and hopefully he's not going to throw some curveballs at me. So
not me, the chat though.
Chat, yeah.
So you gotta watch out for chat.
Yeah, exactly. I'm waiting for it though. So the Redis and ElastiCache, we have been in AWS portfolio for last 10 years or so. And Redis has been in the open source community for quite a long time. And my goal today is to talk to you about real-time applications and how you can build them using Redis, and in particular on ElastiCache platform. So that's the goal for today. Hopefully we spend next hour talking about Redis and showing some sample code for you, and then if you have any questions, happy to answer as well.
Okay, awesome.
Happy to be here.
Yeah, no, we're all excited. We love here on Database Deep Dive being able to bring in the resident experts.
Yep.
Couldn't think of anyone better for Redis and ElastiCache than you. And I know people are going to come into the chat and have specific questions for their use case or questions along the way. So we'll work together to be able to get those answers.
Got it. Yeah.
All right, sounds good. So I heard you have a bit of a presentation and some stuff we want to walk through. Does that sound good?
Yes. I have a presentation. So I'm going to start with the presentation right now. And so many of you know what real-time applications are. Real-time applications, are the ones where like ride-hailing, media streaming, and social apps, leaderboards, and all of these applications, typically consumed by millions of users, terabytes of data. The primary requirement would be that you need very high throughput and low latency, and you're talking about typically millions and millions of transactions per second, and it's consumed from a variety of form factors like mobile devices, IoT devices, and things like that. And so the idea is that what type of data store is useful for you if you have requirements like this. And also one of the things that developers look for when they're building these real-time applications is that they don't want to learn a new API. They want to learn, they want to use something that's in open source, something they're familiar with, and something that they use it in their code on a day-to-day basis. And so something that is very close to that is very apt for real-time applications. And so I'm going to talk about Redis.
Before we get into Redis specifically, every week we've gone through a different database offering. And broadly, basically like the so the problem that is addressed, that is faced by developers on the wild, that solution was purpose built for, right?
Yeah.
And so with caching in general, like everyone, a lot of the themes of previous episodes have been, okay, well, how do I access data in a really intuitive way with like Neptune for a graph database, or how do I, have to develop my schema for a relational database, or so on and so forth. And there have been, iterative improvements for how you can improve usage and access. But I think the big thing with caching is that it is fundamentally like a speed up requirement that you cannot get with on the sub database like tuning level, right?
Yeah, exactly.
Okay.
So I'm going to talk about caching particularly. There are a variety of use cases where Redis can be used, and customers use it in a variety of scenarios as well. But I'm particularly going to talk about caching, and some ways you can actually build a cache in front of your data store and accelerate your queries. And so I'm going to talk about that.
Sweet. And we're going to talk about how Redis and ElastiCache make that amazing,
exactly.
right?
Exactly.
Perfect.
With that said, I'm assuming many of you know what Redis is, but if you don't know, Redis is a key value data store. It's in-memory data store, and the idea is that it's stored in the memory so that you can actually have better throughput and high throughput and low latency. That's the idea behind it, and it has been there in the market for last 8 years plus, and it has evolved over the time, if you know Stack Overflow, which is one of the communities where developers spend a lot of time, Redis is the most loved database for 3 years in a row. #1 most loved database for 3 years in a row. And if you look at database ranking in terms of how it ranks among other data stores, it's #7. So it's really loved by developers.
Maybe you're going to get into this a little bit. But why would you say it's so loved, right? Like, I know everyone, it's like, oh, hey, I can store my data and just access it even faster. Like, no one would say no to that, right? Are there particular things that you think make it really lovable, either through like the developer experience or how easy it is to set up and build? Like, or are those things you want to talk about like a little later on?
I will talk about it, but in net, as a developer for me, the most important thing for me is when I'm writing code, I would like to use APIs and interfaces that are very close to the way I write my code. I use in my code, when I'm writing applications like real-time applications, I use certain data structures, right? And it's easy for me to have a data store that I can use with similar data structures. So like sorted sets, lists, strings, and hashes, and that kind of stuff. And so Redis actually has very rich set of data structures. That's one of the reasons why developers love it. And then the second reason why people love it is that it's open source, and also most importantly, provides you that high throughput, right, and low latency. And you don't have to sort of do quite a few things typically you have to do with other data stores to achieve the same level of performance. And so that's why developers are happy with this.
Awesome. I mean, I don't think anyone would say no to an intuitive developer experience where it's data structures you're already natively writing in, so that you don't have to learn as much about how to make your workflow work with the tool, for example, right? It's like a cleaner handoff, and then second is just the performance, and I think we're going to see a lot about that very soon from your slides.
Yeah, I have a few slides actually to talk about that. With that said, let me introduce Redis to you. The very first thing to talk about is I talked about high performance, high throughput, and low latency several times. So it's obvious. It's open source. It's highly available. It's built for applications looking to get high availability, meaning that Redis has the concept of masters and replicas. And so you can have your master used for reads and writes, and you have replicas that can replicate data so that you can actually have significant number of your transactions going against these replicas to achieve high throughput. And the other important thing is that because you have a master and replica with the same data, you can say when master fails, you can fail over to replica, and without losing any availability, without having any impact on availability. So that's why Redis is designed for highly available applications. Also, it has a significant number of data structures that you can use that I talked about. You can also like sort of take snapshots and let's say you want to save that data in that you have in the in-memory instance, and you can take a snapshot and you can restore that at a later point. Typically, these are not DB files, if you know what those are, but and then you can restore a new instance of Redis from that data. So you have wide variety of options with Redis, and it has transactions too. So that's Redis for you.
Yeah, and what jumps out to me is when you say fast, fast is a very relative term.
Yeah.
But fast with response to 1 millisecond is orders of magnitude faster than what a database pulling from disk is going to give you, right?
Right. It's going to be significantly faster. In fact, we call that, if you look at some of our ElastiCache blocks and few of our documentation sites, right, we talk about microsecond is the new normal, not milliseconds, right?
Yeah.
So we're really talking about a significant throughput. On some of our nodes today, where we specially tune Redis for AWS and some of the instances like R5, we can get up to 450,000 transactions per second on one single node.
Wow.
And then if you distribute your workload across multiple nodes, you're talking about millions of transactions.
Wow.
Which is hard to achieve on other data stores.
Yeah, and so I think you just introduced the concept of the running and managing the open source variant of Redis versus using an AWS managed service for Redis.
Yeah.
And so what are the, I know obviously it's more challenging to roll your own, but what are the specific challenges that people
That's exactly what I'm going to talk about.
Oh, okay, wonderful.
So, great question. So now that you know what Redis is, you can say, look, I can put this on EC2 and manage it for yourself. And many of our customers, they tried this too. But if you really think about total cost of ownership, when you're having Redis or your workload on self-service EC2, it's difficult to manage. Why? You want to provision hardware. It's not. And you want to configure that in such a way that it's really optimized for your application. You want to make sure it's compliant with security, so you want to patch the nodes. And if you want to, let's say, add more replicas, or if you want to add more nodes, it's hard for you to do it on your own. So if you look at all the things you have to do on hosting yourself on EC2, your total cost of ownership and the sheer amount of work that you need to do significantly is higher. And so that's where ElastiCache comes into the picture, right?
Awesome.
With ElastiCache, just like our other database services, we are fully managed, meaning we are providing you a fully managed solution. We are tuning Redis, which is unique to ElastiCache for AWS instances. What that means is that for M5s and R5s, which are the ones we introduced about almost like 10 months ago, and we specially tuned Redis for these instances. And what that meant is that if you take open source Redis and run it on R5 versus if you take ElastiCache Redis and run it on R5, you're going to have 80% incremental throughput.
Exactly, and that's just a fundamental trade-off of building generalizable software, right?
Correct.
It's like when you want to build software that is applicable in a large number of environments, building that compatibility in means that you can't both also specialize in making it ideal for one hardware configuration.
Correct.
And so at AWS, we're able to do that and essentially just get more bang for your buck for what would be the drop-in replacement from a syntax perspective.
Exactly.
For Redis. So.
Exactly. Like I said before, you can get up to 450,000 transactions per second on a single node on a tuned ElastiCache instance. Also, fully managed, obvious for many of our AWS services. We take care of, managing hardware, provisioning. If you want to add new nodes, new replicas, you can do it in online fashion. You can just say, I want to add new replicas. We just do that for you. You can add new masters, meaning you can distribute your data across multiple masters. All of that is online.
Wow.
And we also manage security for you. We patch it as required. And most of the times without any downtime. And if you're using ElastiCache in a highly available configuration, what we do is that if your master goes down for a variety of reasons, we auto failover, and so you don't have to do any of that stuff, and so you will not have any availability impact. And most importantly for big enterprises, and the compliance certifications are very important, like FedRAMP, PCI, HIPAA. We have achieved all of those complete, compliance certifications, and so we manage according to each of these compliance regimes, and you don't have to take care of any of this.
Yeah, and I was going to say, but you brought it up with fully managed system. Anytime you're working with data, being able to guarantee that those security patches are automatically applied is just a huge benefit, like both peace of mind that you don't have to worry about waking your DevOps engineer up in the middle of the night to patch your servers, but also having to make sure that you are a leading expert and have to think about that. Like with a managed service, you get to inherit that expertise from AWS folks.
Exactly. And icing on the cake is that it's still open source compatible. So we are not breaking any compatibility. So, and then we also have, every time we have a new version of Redis, we make it available really, really fast to customers, and so within a few weeks. And so you don't have to wait too long for having the new version, and you can continue to get all that value you get with open source, and you don't have to worry about anything. Set it and forget. So easy.
Wonderful. So you have me sold.
Yeah.
Real-time data, please use cache, Redis, ElastiCache. But what does this look like out in the wild? Do you have examples, or maybe can we walk through a use case of how setting this up would look like?
Exactly. So what I'm going to run through today is set of scenarios, use cases where Redis is used, and I will talk about some of the sample code also, and then explain why it is used in which way, and then some of patterns, I would say. And then obviously there is tons of documentation out there regarding ElastiCache, and then you can just go research on a specific topic, and then you'll have enough documentation for you to launch something.
Beautiful. Let's get into it then.
All right. So talking about real-time examples, right? Real-time application examples. As you know, these applications, they fall into multiple categories of use cases. In our own customer base, caching is something that's widely used in terms of leveraging Redis. Leaderboards is another great use case that customers use significantly today. Session stores, and I'll talk about each one of them a little bit more details later. But leaderboards, real-time analytics, and geospatial analysis, and variety of use cases where Redis is used. So let me talk about each one of them. Let's start with caching, which you asked me a question before.
Yeah.
So the idea here is that you want to accelerate your applications, and you have high throughput and low latency needs. And typically, when you start writing your application, or when you're designing your stack, you're picking a data store for a reason, and you're picking the data store because the way you organize the data. Typically, you can say, look, my data has several entities that I want to connect closely, like the employees' addresses and things like that. And you might choose to say, I want to have this in a relational data store. And then what happens is that your real-time application is consuming that data store. All of a sudden, you have traffic spikes. And so now what do? You need to scale them. Now, when you scale them, typically you scale them two different ways. One is you have instance-based. Basically, you're going to add another instance, which is cost, right, for you. The other way you do that is that if you're using an application like Dynamo, where you're using pay as you go, and then you are having more transactions on it because of the needs that you have in the application, and then also it's not cost effective that way. What you can do is you can actually take Redis, put it in front of these data stores, in conjunction with those data stores, accelerate your queries, accelerate your transactions, and at the same time, it's cost effective for you as well. And so that's where caching is used significantly. So let's talk about a sample topology where Redis is in front of a data store. So what you have here is RDS is used for storing your data.
Again, this is confusing to some people who have never seen it together, because people always pronounce acronyms in weird ways or different ways, right?
Yeah.
And so I have personally, like, even before I was aware of any of this, was like, oh, is RDS and Redis the same thing? Amazon RDS? No, again, RDS, Amazon RDS is Amazon Relational Database Services that consists of like MySQL or Aurora, particularly. So no, Redis and RDS are not the same thing, even if it sounds like you'd pronounce their acronyms the same way.
That's a good catch. RDS and Redis, the pronunciation is kind of close. RDS is a relational data store, like Nick talked about, and you can have, Postgres, MySQL compatible relational data stores. You can have even SQL servers, Oracles, and whatnot. Aurora is our own relational data store as well, but RDS and Redis are different. Redis is ElastiCache. Redis is in-memory data store. You provision this separately, and you can launch your own clusters and all of that, right? So
again, an in-memory key value
data store, exactly. And you might also have heard about Memcached, which is another in-memory data store that we offer in our portfolio. But Redis is a lot more rich in terms of data structures, and it's designed for high availability. So a lot of people find Redis being more useful for their use cases. So going back to the caching use case, now you have your data store either in RDS, which is relational data store, and DynamoDB, which is a key value data store, but with infinite scale. The idea is that you have a client application, fronted with load balancing, and the idea is that suddenly traffic spikes, and it's not cost effective for the reasons that I explained.
Yeah, and so to go specifically into why that's not cost effective, right? Like you explained before, in the Dynamo world, it's like it's per transaction.
Correct.
And in the other world, you have to manage your connection pool. And if you either blow up your connection pool and it's completely flooded and you can't get connections to the database and requests go unfulfilled,
correct.
Or you have to scale out to fulfill this sudden spike in traffic.
Correct.
Yeah.
So those are the two reasons, and also, most importantly, the performance characteristics of these data stores are also very different, obviously for a good reason. And if you organize the data very well, obviously it affects how you perform, right? So the different reasons why the characteristics are different, but Redis has, in-memory data store. That's why you're getting, incremental throughput and low latency. And so what you do in this case is that you build a cache, and the way you build the cache is two ways. And so this is sample code that you're seeing on the screen. So there are two ways to build the cache. One is write through. What that means is that when you're writing some piece of data to a data store, you would say, I'm writing to the data store as well as you're writing to the cache at the same time.
Yeah.
What that means is that every time you read that data, you're always going to find that in the cache, and it's going to be, you're not going to go to the data store anymore. You're always available in cache. Yeah.
I think this will make for a great diagram.
Yeah.
I don't know how well it'll come through, but I'm trying to get some eyes here. So I think that there's three entities here, right?
Yeah.
So we have the client.
Yeah.
This is box number one.
Yeah.
Then we're going to have our cache.
Yeah.
So this is going to be either, and this font I know is going to be pretty small, so
Yeah,
I'm sorry.
it's the picture before that picture.
But yeah, so we're going to have our cache here in the middle, and then we have our DB, which is over here.
Yep.
And so we're describing the first scenario, which is going to be write through, right? So write through, we'll do this in green. I'm sorry, I know green is probably not going to show up well at all.
Maybe because of the white background.
Actually, here, let's go to live video.
Yeah.
Okay, this is so much easier to see.
Yeah.
Great. So we're going to describe write through first.
Yeah.
Right. So you said that we're always going to instantly hit the cache in a write through scenario.
Yeah. So let's say a client has some piece of data that you want to write.
Yeah.
So what you do is that you write to DB as well as to the cache.
Okay.
So that's called write through.
Okay. And so how does that happen? That's not two separate calls. That's one call that writes to the cache, and then that also goes there? Like, how does that work?
So today customers do it both ways.
Okay.
Some customers write it from the application itself, which is client. They say, okay, I'm writing to the data store. I'm also writing to Redis.
Okay.
Yeah, so two calls, right?
Okay, so I'll just draw.
Yeah. And some customers actually what they do is that they write to the cache, and from cache they have a stream that's going to the data store. They also do that.
Yeah.
But many of the customers actually do this.
Okay.
They write to this for write through.
Great.
And then the idea behind this is that, when you're reading this data from cache, you're always going to have 100% cache hit ratio, right?
Yeah.
Because you're always going to find it in the cache.
Yes.
And it's scaled, distributed, and so you're going to have that significant, throughput from cache.
Yes.
So that's the idea.
And that's right through.
That's right through.
Okay.
The second way of spinning up a cache is what we call lazy loading.
Okay.
So what that means is that you have a data store. Data store has significant amount of data, but you might have only part of that data that you want that to be hot, and part of that data to be it's cold. You're not going to read that as much. And so in which case, there is no point putting all of that data in the cache.
Exactly.
And so what you do is that you say, hey, very first time if application wants to read the data, so you go and say, hey, cache, do you have my data? So you make a call and say, yeah.
So lazy loading.
Yeah.
And so
you go to cache and say, hey, do I have my piece of data, right? And cache says, no, I don't have it, right? Yeah,
and then
it says, I don't have it.
No.
So then you read from data store and put it in the cache. Correct.
And then the cache still returns to the client.
And then anywhere afterwards, you read that data, it's always going to be in the cache. But if application is not reading piece of data, cold, it's still in the data store. You're not, over-utilizing or putting everything in the cache.
Yeah, and there's reasons why you wouldn't want to just put everything in the cache, right? Like, because in theory, it's like, oh, it's so much faster. Oh, it's just a key value access, right? So why would we not throw that all there? Could you explain a little bit about how, while memory is much more efficient, like how does the cost compare to the equivalent like database sort of structure that runs from on disk, right? Like how do those compare?
Yeah, so it differs from your data storage system to data storage system. Typically, in any hardware environments, right, reading it from memory means that your data is already read through your I/O, whatever, and put it into the memory. So reading it from the memory is really fast compared to going to the disk and reading it from the disk. Now, the disk, the type of disks you are available, NVMe's and SSDs, they are evolving as well, but still reading it from the memory is still way faster than reading it from the disk. And that's why you see that performance differentiation.
Yeah, and so another thing with, and I don't know if you're getting into this with best practices for caches, is like there is a performance reason why you don't want to just throw a huge data set into your key value store, right? Like how does the size of your cache, even though it's a key value store, how does that impact the performance of your caching calls?
Yeah, so as such, the size of the cache doesn't impact the performance, but the nature of all the data in the memory means that you have a memory limit on a node, right?
Exactly.
So you can't load more than what you have on the node, and so and the nodes we provide today on the AWS platform are, you have significant amount of memory available, and so typically you don't run into a case where I can't fit this in the memory. If you have a need like that, you can also distribute that across multiple nodes. And that's where Redis has the concept of a cluster, where you can say my data can be distributed across multiple nodes, and which means that you can store, like today we support up to 250 nodes.
Wow.
Which means that if you take our
largest instance size.
We're talking about terabytes and terabytes of data.
Wow, okay. And then you have that all in memory. Like,
all that in memory.
So in reality, data size is not a limit for customers that are looking to do caching right now.
Correct.
Awesome.
And so there are other things which I'm going to talk about when you are in the caching scenario, which I can show you in the slide actually.
Yeah, sure.
So some of the things that you want to pay attention to when you're writing your application, and if you're using caching pattern, is that and by the way, ElastiCache, we publish several metrics about your workload, how Redis is actually running your workload, and so in this particular use case, caching use case, the things that you want to look at are cache misses and cache hits. Obviously, your cache hit ratio has to be high. then then your performance is going to be as expected, right? So if you don't have a key in the cache, obviously it's a cache miss.
Yes.
And so this is where these patterns are important. If you feel like your entire data set is hot, you want to keep that in the memory. If you feel like, look, there is a cold data and there is hot data, you want to use lazy loading and load it appropriately. So that's one way. So that's one thing that you want to look at, cache misses and cache hits. Then there is the concept of freeable memory, meaning that your cache is consuming X amount of memory, and then there is this much of memory available for you. So if you want to, let's say, add more data into the cache, you can look at that and say, do I have enough space for me to add? So that also helps you. Then there is the concept of reclaimed data, meaning that you can say you have certain set of keys. Key is a very fundamental concept. You can say this is the name. Let's say location is the key, and you could say value could be Seattle or Los Angeles. You can say on this key there is an expiration, and Redis, what Redis does it for you is that when there is expiration time, it just takes the key out from the memory, right? So you can also manage your hot and cold data that way, and also ensuring that the data that you have is up to date, right?
Yeah, and so essentially what you're describing is broadly the concept of your cache policy.
Correct.
Right? The cache policy, again, is the rules by which data will be either, I forget the exact term, but put into the cache, and then I know the other term for getting them out of there is evicting them from
Correct.
the cache, right?
Eviction, yeah.
Eviction, yeah. And so let's say you have a fixed cache size, and that could be for a number of reasons, right? Based on what your architecture is, your cost requirement, or just your data access pattern, right?
Correct.
Let's assume that based on your traffic, you only have a certain amount of data that will be hot, or that you have a predictable pattern for it. There's no sense in keeping data that will be cold, even if it's not cold yet, right?
Correct.
So essentially, these are all examples of being able to visualize the cache policy. And is there a way to tweak that specifically? Like I know LRU is a very common cache, least recently used, right? So once it becomes cold, once it becomes the least recently used one, pop that one and evict it.
Yeah, so Redis natively supports different ways of evicting. So LRU is the default one. Basically, the default one is that if you have any keys that are expired or set with an expiration, the default policy is when there is memory pressure, it's going to go through all those keys and say what are the least recently used keys, and then take them out. You can also set and say, irrespective of the expiration set on these keys, you can just go through the entire keys and say anything that least recently used can also be evicted. And so there are a variety of like 5 or 6 different types of eviction algorithms available, and customers use it widely to manage.
The expiration date essentially is on a per item basis. Essentially, it's a guarantee, right? Exactly. Even if new things aren't being pushed into your cache, you can guarantee that it will no longer be there beyond a certain time.
Correct. Which is important. In another use case, I'm going to talk about session stores, where these sessions are actually valid for a certain amount of time.
And I mean, even if you have like I don't know if I'm like jumping the gun here, but like you have an auto-scaling Redis cluster, and you don't want to have to worry about that scaling. You just want to know that like, okay, I'm happy to scale this up as much as needed for my customers, but then I can also guarantee that all of the data that I put into there has an expiration date, and I don't have to worry about like these vague concepts or things that you have to like test essentially. You know that there is that hard limit for expiration that it will then hopefully scale back down for.
Exactly.
Perfect.
Exactly. Right on money. So let's move on to the other use cases, right?
One quick question actually from the stream. So Milky Way 007 Galaxy is asking a little bit about what we were talking about before.
Hi, Milky Way.
So why is Redis and ElastiCache, can they cache petabytes of data? They missed it. So I think this is in reference to the conversation we were saying before with how Redis caches data in memory, and then we can have a cluster with Redis. And can you talk to basically the instance types and how they play in the cluster, and basically how that scales the size of the data store you can have in Redis?
So I believe the question is the capacity.
Exactly. How does capacity spanning and what
So the way it works is that when you have your data, like I said, all the data is stored in the memory. Now you can say you can pick an instance today. If you pick a largest instance today, let's say R5 instance, right? And you can store, significant amount of data. And you can say, I want to have a cluster of X number of nodes and spread your data across all these nodes. Now, that's what I was talking, we have a 250 nodes limit today, which is like a soft limit, but you can have 250 nodes of your largest side R5, and that's what I was talking about, 170 terabytes of data you can have in one cluster, right? Now the question is, can't you scale even further? Sure. Is that the question, right?
I mean, it was just generally like they had mentioned maybe on the tail end of our conversation that it could get to that size, and they were probably wondering how. So I guess really the only limit then is as long as your total size is within 170 terabytes. Yeah. And obviously, I guess like let's imagine a scenario where you have like some obnoxiously long value, right? Like as long as you had, you could fit that key and that value for one object on a single node with as large as it can be, which is like not a realistic scenario where you have one entity, right? So in reality, your upper bound is now just the maximum size of the cluster, which is 170 terabytes.
Correct. Correct.
Cool.
And the way that may be in the question as well is that if you're consuming that data, in a cluster you can say there are clients written actually for open source clients available for the cluster mode Redis, and then you can actually use these clients to read the data from any of these nodes, and they're specially tuned so that it can operate in that mode, and you don't have to really know. There is one endpoint you can say, I want to get this data from here, and you can get it, right?
Okay, yeah. So that was a personal question I had with respect to when you scale out the cluster. Like where is the master? Where is the endpoint or the entry point to interacting with the cluster? And is this where having like a multi-master is significant? Or particularly in a more pointed question, Seattle Fox 7 asks, in a cluster, does a key need to be fit on a single node? So I guess that's like more of my previous like crazy scenario where you have a key with a value that could exceed the size of a single node, right? Yeah. But that's just like, I don't know, could you think of examples where that happens?
So I mean, this question comes up too, which is very rare in the case that you can have a key. Today, a key can only exist in one node. Okay. It can't span across multiple nodes. Okay. And so the idea is that if you have a key and you have value for that key that can't fit in one node, that means you're not designing your application well. Okay. You don't want to have so much data.
It almost looks like you're putting a database as the value for a given key.
Exactly. It's very rare cases actually that is appropriate, but many of the cases what you really want to do is that you want to design the keys in such a way that it's granular enough for your application, and you could read it really in a way that you get that high throughput.
Yeah, so this actually like schema design for NoSQL, keys and sort keys. We had an amazing episode. I think it was maybe our second with Rick Houlihan from the Dynamo team. Yeah. And so all of the things he spoke about with like sort key and index key design all apply here then, I guess, as well, right, for Redis. It's all just key value, NoSQL-esque type format. Yeah. So if you're interested in schema design for for Redis or other NoSQL applications, definitely check out episode 2 or Rick Houlihan's talk from reInvent.
Awesome.
It's on YouTube. It's always a pleasure to talk with him. He's amazing.
Yeah.
So we've got some more use cases. Do you want to go through those?
I have more use cases. So
I'm pumped about Redis. I want to see where people are using it out in the wild.
Yeah. So another use case that is widely used by our customers is Session Store. Okay. Session Store is like we just talked about it before. Typically if you have an application, right? Let's say you have an application that's like a website or whatever. And if you are setting that up in an auto-scaling group, right? So your application code is running on different nodes. You don't know where it is running. Now, you authorize your users, and you have a session, establish a session with some time period, right? And so now you want to store that without having to lose that state. You want to keep that session alive irrespective of where your application is running. And so what you can do is that you can spin up a Redis instance, and you can say, which I have the code here. Let's say you have a PHP application. This is pseudocode, not exact code, but you can say, here is the session, and I'm going to save. There is only one endpoint, cluster discover endpoint, and you can say, hey, look, I would like to have this data available as a session in that store, and I want this to be persistent, and I would like this to be, some sort of level of timeouts or whatnot for that endpoint. So, but your session state is stored on Redis and available to you wherever your application is running, irrespective of where it's running.
Yeah, so with respect to and again, correct me because this is my interpretation of this code snippet right here. This does a lot of things that could be really complex under the hood, but right out of the box. So first is you're hitting an endpoint for the cluster that is persistent regardless of the size or where that key lives on the cluster.
Correct.
That's amazing to begin with. We just had the data API released for Aurora, I think. So that was super powerful. Similar concept here. You're defining in a certain way the eviction policy also because you're defining the timeout here.
Correct.
The read timeout as well.
The timeouts I have is sort of more like it's a connection timeout because if you're establishing a connection, you're saying, look, I don't want to spend more than 2 seconds to establishing a connection. And another timeout is for basically when you're reading, you don't want to spend too much time. So that's the timeouts, but not necessarily for the session. The session use case is that when you start writing session data, you can say on this, just like keys and expiration that we talked about before, you can say for this particular key, here is the expiration, right? And then your session only lives for that long, no matter where your application is running. And once again, this is very popular use case, particularly for applications running in auto-scaling groups.
Okay, awesome.
Yeah.
And then persistent is number of, I guess, like the minimum or like the scale down?
Basically, want the connection to be persistent. That's what.
So that's binary. That's just 0 or 1. Okay, cool.
And then the other use case that's emerging is analytics use case. And the idea here is that today we have Kinesis, which is a streaming platform today. And customers use Kinesis, they stream data, and then they have something that is consuming that data and doing something with that. Typically, analytics is one of those use cases where you're taking data from the stream and provide analytics on that, right? And so the idea behind this is that streaming typically is very noisy. The data is coming from IoT devices, data is coming from mobile devices. You don't have enough time to do any processing there. You're streaming it really fast to a platform like Kinesis. So now the idea behind this is that now let's assume in this case what you're seeing in the screen is that there are two different use cases here. One is you have Kinesis data that's coming from your application, and you have a Lambda function that is consuming your stream. And then now you have a use case here where my application that actually is interested in analyzing this data may not need exactly all the data that is in the stream, right? And also you might have a use case where some of that data needs to be retained somewhere else. And so you can actually use Redis and say, I'm going to take the data, Lambda function can read the data from the stream, put the data that is absolutely required for analytical purposes in Redis, and then your application actually uses Redis for analysis. And then you take the data that's required to be retained and you write it to the data store directly. So that's the use case here.
Awesome.
And so you are getting very an analytics application running with really fast and without any performance hiccups of reading data from the stream. And at the same time, you're retaining data, right, appropriate to your application.
And again, you have this Lambda here that auto scales to that works so well with Kinesis data stream because you don't have to think about the scaling. You just know that for each data or event in my data stream, spin up a Lambda, and then you get to write all the custom code to determine, well, what am I going to consider hot data? What am I going to consider cold data?
Exactly.
And then you pipe that to ElastiCache or Dynamo.
Exactly. And then the second use case is very similar to that. In this case, it's slightly different. As you can see, the data is coming through Kinesis stream, and then Lambda function is still consuming that data. But then what you're really using it here is that you're taking that noisy data and you're actually processing it within the Redis. Why Redis is useful? Because you have all these data structures in Redis, like sorted sets, lists, hyperlog logs, and several rich data structures, which can be used to aggregate data, dedupe, and clean the data pretty much
So this is sometimes like the part of like ETL, right?
Yeah,
Large
exactly.
processing jobs.
Exactly.
And so the beauty of this here is that like instead of throwing all of your noisy data directly into your database and then telling your data engineer like, hey, deal with that later, or your data scientist like, yeah, you worry about cleaning it. You can actually have this as part of your pipeline, and it's really not that hard to be able to clean up with Lambdas directly with Redis.
Redis, yeah. Redis particularly, like I said, the data structures you have, like sorted set, for example. You can dedupe stuff from that. You can sort the data, and then you can send it to another Kinesis stream that can be consumed, which is more clean version of the data. And then analytics applications would be a lot more, performs well in that mode, dealing with the data that it requires than, again, spending time to clean the data at the application.
Because it's like if you don't clean it then and there directly through using Redis, you're putting it into, let's say, another data store, like a database, like I don't know, Dynamo or whatever.
Right.
And then you then have to still call it back out. And so it's like kicking the can down the road, right? It's like if you have to clean it eventually and you know that noise is really just that, it's just noise, you might as well clean it as efficiently as possible directly off of the data stream so that you fix the problem as far upstream as possible.
Correct. Exactly. Now, icing on the cake is that, let's say, here is the use case where, let's say all your data, the most critical data you need for analysis is in Redis itself for a variety of reasons. Now you can say, look, instead of using Kinesis, right, I want to stream data to my Redis instance. How do you do that? There is a data type called stream data type within Redis itself.
Wow.
So it's basically built based on Radix tree. Basically, it's optimized for range queries. And then the idea behind that is it's almost like a list. So you push and pop from it. And so you can have publishers writing stream, and you have consumers who can consume the data from it. And so some sample code here. It's simple for you to add. You just say x add, and you can add a stream. In this case, example I have is that you're tracking device locations, let's say from IoT devices. You can say, here is the ID for the device, here is the lat longs for it, right?
So this is, like quite literally going to be like if you have a GPS sensor and it's moving, you know the time that you added the data to the Redis data stream, you want to know what device it is and the ID, and then latitude, longitude. And like once you set this up, you have essentially a persistent stream for that data.
Correct, exactly.
Great.
So you add that, and then there is a sequence number that is generated for each of the unique items you add in the stream. By default, you don't have to do anything, it just generates one. Or you can have your own, but the idea is that it generates one, you use it, and then if you want to read it, you read from the stream. Very simple. You can just say, just give me the last piece of data that got added, or you can say, give me the specific one, and you get the data from the stream.
Yeah, and so consumers just need to know the ID of the stream on Redis to be able to subscribe to it and pull the data in whatever fashion that they want.
Correct. In typical use case, where you do is that you are reading the last one from the stream.
Yeah.
So that's pretty simple. You
Especially
don't
with real-time applications where you want that data to be turned around as quickly as possible. You're not waiting, having the super efficient data store and then still holding off and doing batch processing usually.
Exactly. And then the other extension to that is that in certain use cases where the stream is coming and the processing of that stream has to be distributed between multiple different things. Like let's say, part of that data needs to be handled by one piece of code, another, part of the data needs to be handled by another piece of code. So there is this concept of consumer groups. So you can say, I'm defining consumer group, and here is the range I'm going to process, and another consumer group process from that range. And so you can also have flexibility in terms of how you process the data. And so the way you do that is you create a consumer group here. It's X group create, and I'm creating a group, and I'm saying by default I want to process everything starting from index 0. So in this case, and then and then what you're doing is that, hey, I'm reading from that group, right? And all I'm saying is that give me the latest one that's not delivered to any other consumer part of this group. Right? The same way, you can say one other thing that's very important in streaming data type is that all the data that you're streaming is in the memory, right?
Yeah.
And so, as I talked about, you want to be managing how much you're storing in the memory. And so the idea is that if you acknowledge and say, look, I read this piece of data already, and that's how you do it using exec. Basically, you're acknowledging it. Once you do that, that means that Redis is going to go delete that item from the stream. So you can efficiently manage the memory you have for the stream.
Awesome.
Yeah. So that's stream data type, and it got introduced from Redis 5.0, which was released about 10 months ago, and many of our customers use it today.
Wonderful. It's easy to see why, right?
Yeah, exactly. Yeah. And once again, we have metrics. Some of the intelligence that we provide to customers is, how much memory you're reserving, on the node, which is, to make it efficient. What we say is that, hey, only use 75% of the memory. Don't use 25% because Redis has this concept of replicating data, and you need additional memory to process all of that. And we want to make sure we are running the instance for you in a way that you don't have any problems of running out of memory. Mm-hmm. So what we do is that we say, hey, our guidelines, which you asked about before, is our guidelines is, hey, have 75%, use 75% of the memory, and don't keep 25% reserved for all the additional processing you have.
Yeah.
For replicating data.
I guess the other thing is, depending on how quickly you expect your workloads to spike, you could basically give yourself a designated buffer range before you tell the cluster to scale up, right?
Correct.
Or introduce another node, for example.
Right. So once again, there are metrics for you, and you can say there is a metric that says, which I don't have on the slide, is called bytes consumed by the cache. So you can say, hey, I want to keep up to, let's say 75% of the data, 70% of the memory for my data.
Yeah.
You can say number of bytes used by the cache is X amount, and if it is within the 75% range, you're great. You don't have to do anything. But if it is going towards 70%, you can say, look, I want to add a new, I wanted to scale it out, and I want to add a new node and distribute the data across multiple nodes. You could do that easily. And it's all online. You don't have to take any downtime for it. It's online. You just come and say, I want to add new master, and we distribute keys for you, and without any downtime. So
yeah. So okay, no downtime. No downtime is awesome. To enable that auto scaling for a Redis cluster, how do they do that beyond like setting the parameters for where scaling happens? But like how would a customer actually enable auto scaling for their Redis cluster?
So they have APIs, which is our control plane. They can call our APIs. Or they can use CloudFormation templates, or they can go to console. You can go to any of these places and say, I just want to add one more node.
Wonderful. So is the adding the node to the cluster is manual, or is there auto scaling?
So it's online scaling. It's not auto scaling.
Okay.
It's online scaling, meaning that the application doesn't have to take downtime. It can continue to access it, and the data will be distributed.
Okay.
So that's why we call it online. It is not auto-scaled.
Okay, so again, the popular ways that people can do this, like you just mentioned, either an API call to increase the node size in your cluster.
Yep.
Through the console, you can do that directly through the ElastiCache GUI.
Yep.
Or over, I guess, like the SDKs,
APIs,
right?
Yeah,
APIs, SDKs that you're
or
already...
Or CloudFormation templates.
CloudFormation templates, okay.
Yeah.
Awesome.
Any of those things, right?
Great.
So so that is streaming.
Yeah.
It's an emerging use case in terms of real-time applications, and then several other use cases too. Geospatial is another use case. Here is where you talked about Neptune, right?
Yeah.
Neptune is tuned for sort of querying about relationships and things like that. And so now let's assume you have a use case where you want to know at any given time your application shows what are the restaurants liked by my friends nearby me. Now, you can go query that data in Neptune and say, what are the restaurants that liked by my friends? That's easy to do it in Neptune. But now you want to say, how many of these restaurants are in the proximity where I am in? And so that is geospatial, right? And so that type of thing it's hard to do in Neptune. So what you can do is that you can take those restaurants that liked by your friends, and you put it in Redis, and you run this command called GeoRadius, and you say, here is the list of restaurants, here is my location, I would like to get it in 10 miles range. And it just tells you what are the ones in 10 miles range.
Wow. This is so interesting because it's like there are very few features where I look at a feature and say like, hey, I can imagine exactly who will use this, or like an entire businesses and products that are built on top of this. Like anything like maps, apps, applications. You're looking for food recommendations. This is so core to that type of to that application, that having that enabled as a feature of your data store rather than application code that you have to write, and knowing that it's going to be optimized for the data store, like that is so much of the heavy lifting pushed off onto the tool that you're using. That's amazing.
And you're significantly saving time, and you're spending more time on writing something specific to your application in your company than these things, obvious things that we can provide you.
And again, like the whole thing with one of the largest value propositions is don't focus on undifferentiated heavy lifting. Let AWS handle that, right?
Correct. Exactly.
You should focus on your application code. And when there are enough developers out in the wild that are writing the same application code to be able to find entities within radius for that long of X, Y. Eventually, someone at Redis was like, "Hey, we should throw this directly in our application code."
Exactly. So that's geospatial. Another interesting use case, more closer to pitch audience, is leaderboards. And so you have games and sales leaderboards, game leaderboards, and the idea behind this is that at any given time you have leaders emerging, and with some level of scores, and you want to know what the ranking is. And so Redis data structures are really tuned for this. And so there is a data structure called sorted sets. So basically what you do is that in this case, I'm adding 4 different users and their ranking. And so now how is it useful? Now once I add it to sorted set, it's already sorted for you. And you can just query as simple as, hey, get me the the list of users in the reverse. Basically, what I'm saying is that who has the highest ranking. And so what it does in this case is that, look, in this Derek is the highest ranked based on the score, and Barry, and Andy, and Carl. So it's as simple as that. Now let's say if we want to add, for Carl a new score, we just write for Carl, here is the new score. If it is already there, it just overwrites that. If it's not there, it adds to the sorted set. And then again, you query and say, what's the new leaderboard ranking? And you get new leaderboard ranking. Now, Carl is in the top. So it's as simple as that. Many of our customers use it for leaderboards. It's very very popular among our customers.
Yeah, I'm genuinely surprised how many clear-cut use cases there are for what are essentially features at the data store level, but are things, again, that are so widely required for processing your data and displaying it. I just feel like I've never experienced that as much as I have with Redis and ElastiCache here.
Exactly. Yeah. So once again, leaderboards is very popular use case. And then another one I want to quickly run through is chat and messaging. Now, for developers out there, the concept of publishers and subscribers and that kind of stuff. And so in real-time communication, it's very important to sort of publish, set of things that you're interested in, and have people consume that if they're interested in that thing. And so it's different from streaming, because in this case, you're not storing data anywhere. All you're saying is that I'm going to publish it. Whoever is listening to it, they can listen to it. And so there is the concept of pub and sub in Redis. And so what you do is that they're categorized into channels. You can publish to a specific channel, and the consumer can say, I'm interested in this channel, right? And so anytime, you can say as simple as I'm subscribing to, in this case, somebody's subscribing to a sports channel, and somebody is publishing to the sports channel, and say, Patriots is a good team. Perhaps Seahawks is also a good team. But and then a client who is interested in saying, hey, I'm interested in this channel, so all the messages being posted in that channel are streamed to the client.
Interesting. And so just taking the one step back here, it's like you can programmatically create a channel, and knowing what the result of the channel ID essentially that's assigned to that channel, be able to tell your application code to then subscribe to that channel directly. So this is, you can really make this end to end just from an event-driven sort of architecture.
Correct. Specially tuned, exactly. Specially tuned for real-time communication. Like you can build an IRC channel
Yeah, so like exactly a chat room, it gets spun up at a discrete moment,
exactly,
and then you want to be able to immediately have one or many subscribers, and then let's say a message hasn't been sent in X amount of time, and then take the channel down essentially, and then break the subscriptions to it.
Exactly. Once again, this is very widely used use case among our customers, and so that's the last use case I have, and I'm sure there are wide variety of other use cases where Redis is used, and I have very few of them here. But for real-time needs, I'm hoping that you can use one of these patterns and really accelerate your application.
Yeah, definitely.
And then I have some customer success stories if you're interested, or we can take up for questions.
Yeah, so I've been watching the chat. Not too many questions now. We had a bunch before. There was one I answered in chat before, but I'll give it another call out here.
Yeah.
So Doruk asked, and totally reasonable question here, what is the difference between Redis and Amazon ElastiCache? And so I said in chat, but feel free to throw in any commentary here. But essentially, ElastiCache is the managed service offered by Amazon that allows you to use either Redis or Memcached as backends or drivers essentially for the service.
So ElastiCache provides both Redis and Memcached in-memory data stores, and we're fully managing that for customers. Now, how is ElastiCache different from Redis? If you remember, I talked about specially tuning for our instances. So if you take open source Redis and you just put it on EC2 versus using ElastiCache and using Redis, you're going to have 80% incremental, performance benefit in terms of throughput. And then the other thing that you get with ElastiCache, with Redis version on ElastiCache, is that some of the features that we continue to add that are not in open source, for example, encryption in transition, encryption in REST. Both of them are only available in ElastiCache, and so we also open sourced it. And so our goal is to sort of enhance value to Redis, and at the same time make it differentiated experience for running these workloads on ElastiCache.
Wonderful, and again, this is a huge point of value for me is maintaining backwards compatibility, right?
Exactly.
So we can make these improvements internally on ElastiCache with using Redis bindings still for the developer. But the entire point is you should still be able to perform a lift and shift for your existing Redis workload or your code, and it will work exactly as intended. And the way new features are implemented will not break other code that you have written for Redis.
Exactly. It's still open source compatible. You're using the same data structures you love in Redis, and there is absolutely compatibility perspective. You don't have to do anything different.
Awesome. So I think we've got time for probably about one customer story. Is there anyone in particular that you're really excited about, or?
The one I'm really excited about, I think very close to your audience on Twitch, is Epic Games. Fortnite, I'm pretty sure everybody knows Fortnite.
Yeah, no, I'm a huge gamer. Fortnite, I play a lot of battle royales. It's you're hitting the right one for Twitch.
Yeah, it kind of addresses one of the things that we just talked about, ElastiCache differentiation, right? And so when Fortnite, the last version, was released, they the Epic Games team, they really wanted to scale it up, and they were using number of nodes to accelerate their workload. And what they did was, instead of using that, they used the new R5 instance type, which we tuned specially for Redis. And so because of that, they got higher throughput than the nodes they were using before, because of which they actually reduced their cluster size significantly. They saved cost and actually had no issue at all in terms of scaling up their traffic. And so it's one of very successful stories, and we talk about that. We're really proud about that.
Yeah, and so I mean, just like, how amazing is it? You use this open source tool that you know and love, and you know, hey, this should be a drop-in replacement. So you take your code and you literally just put it on AWS instances that are specialized for Redis through ElastiCache, and you can automatically either save. You basically just save money because you can do the same job with the same throughput with a smaller number of nodes in your cluster. And then you just pay less for it.
Yeah, exactly.
Right? So it's like, it's amazing. You know, it's just like, hey, small bit of work for a huge gain.
Exactly. Yeah. So that's one of the favorite use cases we have. Expedia uses us. They have millions of transactions. we have Grab, which is one of the popular ride-hailing use cases. Peloton is another one, where leaderboards is very important for Peloton.
And real time is
exactly
is very important there too, right? Because it's like nothing breaks the immersion of a competition in some sort of race if you aren't getting those real time metrics with respect to where you're standing next to everybody else, right? Like the worst would be you have to pedal for 5 minutes and only like 30 seconds delayed after are you getting the updated leaderboards, right? So that is a completely different experience without real-time data reads.
So and then they use ElastiCache today. So many use cases like that. And I mean, if you just look at the customers that we have, several customers in different categories, telecommunications, social media, media and entertainment, several of those and big names. And so we're really proud of what we provide at ElastiCache, and we hope that customers really, get the benefit out of it.
Yeah, I mean, again, we started off with describing the value prop of caching in general, and I don't think there's a single subject domain that doesn't stand to gain from caching. There are these, very specific industries that can just like have immense gains too, but ultimately caching has a place almost everywhere.
Correct.
So glad to see all of the amazing customers that are using that. But I think we're kind of nearing the end of today's stream.
Oh, cool. Awesome.
So if anyone has any questions, we're gonna stick around for another few seconds here.
Yeah.
Would love to answer any of those. Again, if you have questions broadly, not just about ElastiCache or Redis, please email us at databasesdeepdive@amazon.com. I'm going to drop that in the chat right now. And we will try our best to either respond directly over email or get your question answered on stream with whatever respective episode that will be addressed by. So again, we've open for questions here at the end, but if we don't have anything else, we'll probably wrap it up. So people are saying thank you in the chat. People were saying, there was lots of great information, and I learned a lot too. I love caching, but definitely learned a little bit about streams, channels, stuff I didn't realize was as fully like a first-class feature of Redis and ElastiCache specifically. So
it's been fun spending time last 1 hour with you. So awesome.
Yeah. All right, well, just lots of people saying thank you. Mr. Hex, ID Thief, Milky Way Galaxy, Alex, Leoparidae. Someone was asking about the URL for schema design. I will, as soon as I end the stream, stick around in chat. I'm going to throw that URL. It's a YouTube video directly in there for Milky Way. But Mohan, it's been great. Thanks so much. Everyone enjoyed it. But thank you again for tuning in to Database Deep Dive. This was episode 8 on ElastiCache and Redis. Next week, our co-host Randall will be back. Hopefully he's recovered. He took today off because unforeseen health issues. But again, thank you again for everyone tuning in, and we will see you next week at the same time here at noon on twitch.tv/AWS.
Thank you. Thanks for
again,
spending
everyone.
time with us today.
See you again. Same time, noon to 1 p.m. Tuesday. Take it easy, everyone. Have a good week.